For this next example, we could use finite differences as it says on the screen right now, but I'm actually going to have us use the calculator to help us determine which is going to be the best fit or the best function to fit this data. So to enter this in, let's go back to stat. We haven't done this since last unit, but we're going to go to edit. And if you have anything in there, remember you can always go up. So like say you have a 3 in there, you want to clear out that whole list. You can go up to the column title, hit clear, hit enter, and then you're starting from scratch. But in L1, let's put our x values. So we'll do 4, 6, 8, 10, 12, and 14. Double checking, make sure my numbers are correct. Awesome. And then in the L2 column, we'll enter in our y value. So we got -2, 4.3, 8.3, 10.5, and 11.4. Now what we're going to need to do, I think I'm missing a number. Oh, 11.4 and then 11.5. No wonder. I was like, I thought I typed everything correctly. So now we have the same number of values in each column. Now we want to do, let's just go back to what we did in quadratics. So let's go back to stat, and we'll go to the calculate menu, and then option number 5 is quad reg. And we'll select that, hit enter, and then we can just leave everything here alone. Let's go down to calculate. Now it's going to give us some information here, which looks like pretty reasonable information, but it doesn't tell us one thing that we've used in the past, and that's the r-squared value. The r-squared value is the regression coefficient. It tells us how accurate or how strong of a function it is modeling this data. So in order to turn that on, let's go back to mode, and then towards the bottom. So if you're using an older TI-84 or an 83, actually if you're using an 83 you have to do something else. But if you're using an 84, it'll scroll down a little further. But we want to go down to stat diagnostics and make sure we turn that on. So we make sure that the on has a dark background and light letters. So now let's try that again. Stat, calc, option number 5, I'm just going to type 5. Oops, sorry, my iPad fell asleep. But that's besides the point right now. We don't really need it. So we're going to go down to calculate again. Sorry. Let's shrink this. And I don't feel like starting this video over, so we're just going to go with what we have. There we go. Okay, so we'll go down to calculate, hit enter, and now it gives us an r-squared value of 0.996. That's pretty good. But then let's go to stat, go back to the calc menu, and let's choose a different one. You'll see below quad reg, there's an option that's cubic reg. Cubic reg, we'll select that. We'll go down to calculate, and it gives us similar information. Now it's for a cubic function, and it gives us an even better r-squared value. That r-squared value is 1. Remember, we want our r-squared values to be closer to 1 or -1. So based on what we're seeing here, we're going to say this is cubic. Now again, as I said, we could have tested this out using the first and second, third differences, what have you. And if you were to test it out, you do your first differences. So going from -2 to 4.3, that's plus 6.3. Going from 4.3 to 8.3, that's plus 4. From 8.3 to 10.5, that's plus 2.2. Then going from 10.5 to 11.4, that's plus 0.9. And going from 11.4 to 11.5, that's plus 0.1. Now, obviously, those are not linear because it's not constant. We should be able to find that as cubic. Going from 6.3 to 4, that's minus 2.3. Going from 4 to 2.2, that's minus, 1.8. Going from 2.2 to 0.9, that's minus 1.3. And going from 0.9 to 0.1, that's minus 0.8. So those aren't constant, so it's also not quadratic. If we did this right, this should work out to be cubic. -2.3 to -1.8, that's adding 0.5. -1.8 to -1.3, we're adding 0.5. -1.3 to -0.8 is adding 0.5 again. So again, regardless of how you do it, we found the r-squared value in the calculator is 1, which is really good. We found that the third differences are constant, which is also really good. So we're going to use this information. Again, we just enter this information into our calculator using L1 and L2. Turn that brightness back on. And we're going to go to stat, calc, quad reg, or sometimes quadratic reg. Now, we're mostly going to focus on quad reg and cubic reg, but sometimes quadratic reg is going to be helpful. So let's take a look at a set of data here. And folks, I would strongly suggest if you're dealing with years like 1960, 1970, 1980, those are harder to deal with. So let's just start with 1960. Let's just make that year 0. 1970 will make that year 10. 1980 will make 20. 1990 would be year 30. And 2000 would be the year 40. So let's enter that information in. We'll go to stat, we'll go to edit, and then we're going to start over. We're going to clear out the column. So go up to the column title, hit clear, hit enter, and then go over to this column, hit clear, hit enter. And let's enter in our X values, in this case our years. So this is for the population of a city from 1960 to 2000. We'll go year 0 is 1960. 10, 20, 30, and 40. Oh, not 4, sorry, 40. And then for our populations, again, it's times 1,000. So it's instead of 4,267, it's really 4,267,000. But for the purposes of this, we can just type it in as 42, if Mr. Brasser can type correctly, 4267, and then 518. My goodness. Let's try this again. 51856. I'm sorry, I'm not even looking at the calculator I'm typing right now. 6166 7830, and then 10,812. So with this information, we're going to go to stat, we're going to go to calc, we're going to go down to quadratic, and we figure out that when we go down to quadratic, we get an r squared value of 0.994. That's pretty good. Let's see if we can do better. Let's go back to stat. We'll go back to calc. We're going to choose cubic reg. Cubic reg, if we go down to calculate, remember quadratic was 0.994. Cubic is 0.9999. There's a lot of nines. That's really good. Now, one thing I want to show you, if you go to stat, calc, and if you go to Quadratic Reg has even more nines. 0.999. Actually, scratch that. It rounds it to 1. It's so stinking close to 1 that it just rounds it to 1, which is good, except for the fact that that first value is 6.25 e negative 5. Remember, I'm just going to jot this in the notes. 6.25 e negative 5 is 6.25 times 10 to the negative 5. That's 0.000625. Folks, that is a stupid small number. For what we do, we typically round to only 2 decimal places anyways. So that is it. I mean, yes, it's a little more accurate, but honestly, it's maybe a little too accurate, a little too precise. So even though it's got technically a better r squared value, the cubic has, well, better numbers. So we're going to go back to stat, go back to calc. We're going to choose cubic. We're going to use this as our function. So the value, or the function that we're going to use, is y equals, and then our a value goes onto the x cubed, so it's let's just do 3 decimal places, 0.105 x to the third minus 2.83, rounding that up to a 9 x squared, plus 109.835 x, and then finally our constant plus 4,266.786. So that's as good as we're going to be able to get.